In this video, we will discuss the multiple one-shots symbol, speed key MOS. The multiple one-shots symbol shares some functionality with the one-shot symbol. The MOS groups several independent one-shots into a single symbol. We can begin by locating the MOS in the symbol library. Within the symbol library, locate the timers folder and expand it. Now, find the multiple one-shots symbol. Click, hold, drag, and drop it into the logic folder. Double-click the MOS to expand it into the detail view. As with most logic symbols, it will come in incomplete. We will need to complete the MOS by adding signal names to all the signal lines that are required. The I1 and O1 are required. The reset is optional. The last item we need is a pulse time to complete the MOS. Looking at the MOS, we can see that it can be expanded using input-output pairs. We will add a second input-output pair using the Alt+ key combination. We can add up to 999 input-output pairs to the MOS. All of the pairs share the same pulse time. However, the multiple one-shot symbol cannot provide a way to generate a pulse on a trailing edge of an input or generate the complementary output state that a normal one-shot could. Inputs in 1 through 999 drive the corresponding output signal high for the period specified by the pulse time on the rising edge of the input. A subsequent rising edge of the input while the pulse time is in progress will have no effect. That is, the output will remain high only for the pulse time duration regardless of the state of the input. Outputs 0 through 999 indicate that a rising edge of the corresponding input has started the timer and that the pulse time duration has not expired. The output remains high until the full pulse time duration has elapsed. Once the pulse time expires and the output goes low, it can be triggered again by another rising edge of the input. The reset signal immediately forces all outputs low, regardless of the state of the corresponding inputs. The reset provides a way to cancel a multiple one-shots operation that is already in progress. The outputs remain low for as long as reset is high. Once the reset goes low, then the MOS returns to its normal operation. The inputs have no effect if the optional reset input is held high. If the input is high when the reset goes low, this re-triggers the output for one full pulse time duration. In our example code, we already have a touch panel defined and the MOS added to the logic folder. We will use the MOS to pulse a signal for 6 seconds. We will use that pulse to light the feedback on a button on the panel for those 6 seconds. We will add 2 signals to the touch panel on presses 7 and 8. Call them button 1 press and button 2 press. Highlight both and drag them to input 1 and 2 on the MOS. Add another signal called MOS cancel press to the panel on press 9. Bring that signal to the MOS reset line. On the output side of the MOS, add 2 signals, MOS output 1 active and MOS output 2 active. Highlight both output signals and drag them to the touch panel feedback 7 and feedback 8. Next, we will add the pulse time of 6 seconds. When button 1 is pressed, I1 on the MOS is triggered. This will cause output 1 to begin the 6-second pulse. MOS output 1 active will go high and cause the button feedback to go high, and the button will light for 6 seconds on the panel. If the user presses button 2, then button 2 press will trigger the MOS to start the 6-second pulse on MOS output 2 active. The pulses on MOS output 1 and 2 are independent and each will pulse for 6 seconds from their respective triggers. During any 6-second pulse, pressing the MOS cancel button will abort all pulse times across all of the input-output pairs. This concludes the video on the Multiple ONESHOT's symbol.